Hello React Native developers, what is going on? In this episode, we are demystifying physics-based gestures and animations. So welcome to Can It Be Done in React Native? This week, we get things done. Hello guys, I hope you are well. William here recording from beautiful Zurich, Switzerland. This week, we are doing a request from two friends of the show, Tiffany and John from the Duct Tape podcast. They have this really awesome podcast about web, React Native stuff, as well as some other very entertaining things. I really like this podcast because for me, it's really the perfect mix between getting some technical content about React and React Native, as well as being entertained by sometimes the most random topics. I think they are really onto something great, and I hope you guys check it out. I had the great pleasure to be invited 3 weeks ago. Part of the podcast is that I asked if they had a request for the Can It Be Done series, and their request did not disappoint. They asked me if we can implement this pull to refresh feature from the Things app in React Native. When I saw this request, I got really excited. I got really excited because I was always wondering how can we implement this iOS rubber band scrolling effect in React Native. So finally, I had the opportunity to research how we can implement such effect. I was so happy. And the second reason I got really excited is that this is actually a very common request which I receive because people often bind some sort of a feature to the bouncing effect of the scroll view component in React Native. So here it's a search, but there is all sorts of effects and animations, transitions you can implement using this bouncing effect. And on Android, you don't have the bounce effect. So you need to implement things differently. And often people have asked me, can we have the same bouncing effect on Android? So I'm glad we get to tackle this. So excited. So how would we do this in React Native? So there are two parts to this example. First, we have this scroll view with this bouncing effect. And the second part is that we use the translate Y value of the scroll view to translate the search icon and the arrow down icon as well as the color of these icons. And when we release the gesture, if the Y value is at a certain threshold, we have this search box appearing. So part 2 should be trivial for us, right? This is our bread and butter. We do this almost in every episode. So we translate the icon, we interpolate the color, and we have when we reach a certain threshold and the gesture has been released, we set a state that will make this search box appear. And for the search box to appear very smoothly, we're going to use a transition from reanimated. We do this all the time, no problem. But how do we implement the scroll view? That's the interesting part. So here we could do a matrix based on two variables. Is the gesture active or not? And are we within the bound of the scrolling or not? So based on these two variables, basically we have a matrix with 4 states. Is gesture active and within bound? Gesture active, not in bound. Gesture not active, not in bound. Gesture not active and within the bound of scrolling. So like for the scroll view component in React Native, we're going to have a container and a content. And we're going to measure the size of the container and the size of the content. This will enable us to calculate if we are within the bound or not of the scrolling. So again, a matrix with 4 states. So the first state is gesture is active and we are within the bound of scrolling. So here we simply translate to whatever is the translation value of the gesture. And we will keep an offset because when we activate the gesture again, the translation starts again to 0. So we memorize the last value into an offset. and we simply translate. Pretty easy. So that's state 1. State 2 is that the gesture is active, but we are outside the bound of the scrolling. So that's the novelty part, is how do we implement the friction effect. So I looked at how some libraries do it. So some libraries have a constant value. So for instance, it can be 30%, 40%. So whatever is the translation, they multiply the translation by this ratio. So you could have the position here to be always 30% or whatever is the total translation. So this works pretty well actually, and it feels pretty well, but of course it's not how it's implemented on iOS. And because here we always have a constant value, basically a constant ratio, where this ratio basically should not decrease over time, but we know that the more we pull, the more resistance it becomes, and we won't get this effect. So I was wondering how can we implement it, and I was thinking at some point, I searched many things and tried many things, and at some point I was like, there is some people who also had the same problem than me, and that's Flutter, because Flutter has also needs to implement this effect from iOS from scratch. So I decided to look into the Flutter source code to see how it's implemented. So there is this squirrelphysics.dart file, and they have this friction factor. So I was like, okay, this looks interesting. So let's have a look at this function. And let me plot it. So we have f, which is 0.52 times 1 minus x power of 2. So that's the friction factor. So let's plot this function to see how it looks like. And we want to check it out on from 0 to 1, because you see it's a ratio here that we pass as parameter. So the value goes from 0 to 1. So maybe I can plot 0 and I can plot 1 as well. So here, whatever is the delta of the translation, so from the previous frame, we can multiply this delta by this ratio. So maybe at the beginning you want it to be almost 1, right? So like this, maybe 1. And at the end, you want it to be almost 0. So the more you pull, the more, the less you're gonna add as a delta to the position. So that looks pretty good actually. Here you see we have 0.52. I mean, that's a bit random, could be 0.50. You can really decide, you see, to how sensitive you want it to be, and you can really configure the sensitivity of the friction however you would like. But this is now much closer to what happened on iOS, because here you really have this friction ratio changing depending on how far you are within the translation. So this ratio is going to be whatever is the position of the scroll view divided by, for instance, the height of the container. So at the beginning, it's going to be very small, close to 0. The closer you get to the bottom of the screen, is going to get to 1. Actually, potentially, it can get more than 1, but here you could use a mean so that the ratio never exceeds 1. And or you could make, instead of divided by the height of the container, you could divide by a value which is bigger. But so maybe like twice the height of the container, so you would have 1 at the beginning and really something close to 0 at the end. But this is gonna feel very natural. So that's the second state. Gesture is active, but we are outside the bounds. Now, if the gesture is not active. Gesture is not active, we are within the bound of scrolling. We simply use the decay function from Reanimated. That's state 3. And state 4 is the gesture is not active and we are not within the bound of the scrolling. We simply spring to either here the bottom or the top here. So here you see, the search box appeared, but it springed behind the search bot is spring to the top. And we can of course configure to the spring to see how, what kind of, again, how sensitive we want the spring to be. So that's the fourth state. And I think we can really implement these 4 states very gracefully with Reanimated. So that's the first part of the example. And the second part is that this will give us the Y value. And the second part is going to be using this Y value to interpolate the colors of the icon. So once we reach a threshold, the icon becomes blue. And we can translate as well these 2 icons. When we release the gesture, a search box appears. So we set a state should the search box be visible to true. And we use a transition from Reanimated for the search box to appear very nicely, very smoothly on the screen like it does in this app. So that's how we would implement it in React Native. But what do you guys think? Can it be done in React Native? Let's have a look. Before we get started, one thing, if you are interested to learn the fundamentals of declarative gestures and animations in React Native, please check out my course at startreactnative.dev. My goal with this course is to provide you with all the knowledge and tools necessary in order to build incredible user experiences that will run at 60 FPS even on low-grade Android devices. I'm updating the course on the monthly basis, and if you are following this curriculum, all the examples we are tackling in the Can It Be Done in React Native series should appear completely trivial to you. So I really hope you check it out at startreactnative.dev. Alright, so here I have the boilerplate project, which you can download from the video description in case you want to follow along with this video. And I have a state in my root component, should the shared box be visible or not. So I have the visible property here, default is false. I can set it to true. And I have the scroll view component, so you see here it's set to true. So this is what we're going to use to display the search box. I have the scroll view component with some content inside. And I have the search component, which is the icon, the search icon and the arrow down icon that we see when we are outside the bound of the scrolling. And if I go into the scroll view component, like for the scroll view that you know and love from React Native, we have a container view and some content, and we measure the height of the container, the height of the content using onLayout. This is going to enable us to calculate the boundaries of the scroll view. And I think the first thing we're going to do is to add a pan gesture handler to the content so we can translate the content nicely, so we can just scroll through the content. So I'm going to go ahead and put a pan gesture handler. So pan gesture handler needs an animated view as its children. So I'm going to set animated view. And we're going to need to give a gesture handler. So Redash already was providing some helper function to create the properties needed for the pan gesture handler, but you still needed to create the necessary animation values. So now we have even more convenient utility function, which is called vertical pan gesture handler, which is not only going to provide us with the gesture handler properties, but as well as all the animation values that we need. And I'm putting it into use memo 1 with no dependencies, because when the container height and content height is updated, we trigger a re-rendering, but we don't want to lose the identity of our animation values. So so not only here we get the gesture handler, but we also get the animation values that we need. So here there would be translation Y, velocity Y, and the state of the gesture. And let me check. So this one is imported from Redash. And so that looks good. And I think one thing we can try now, so we have syntax error here, is to apply, so we're going to create a variable called translate x, translate y, sorry, and we're gonna, for now, we are gonna assign translation y, and we're gonna set the transformation into the content to see. So we have transform to see if everything is in order. Let's have a look. So maybe I need to set the default back to false here. And so you see it translates nicely. Of course, since here I'm not preserving the offset, once I release the gesture, I go back to 0. But this we know how to do. So now let's, in the intro we talked about this matrix, 2 variables, 4 states. Is the gesture active or not? Are we within the bound of the scroll or not? So we have really 4 states to handle, and we're going to do this into a function which we're going to call with scroll, and we're going to pass these animation values as parameter, as well as the container height and the content height, so we can calculate the boundaries of the scroll view. So let's create this function. So we have with scroll, and maybe I'm gonna add some types quickly. If you can bear with me while I do that. So this is a number, this is a number, this is an animated value of state, this is an animated value of number, same for translation y. All right, so now we can return our block of instructions. So since we're gonna need to apply a spring function and a decay function, and we need to create a state for these 2 animations. Luckily, these 2 physics-based animations share the same state. So I'm going to create a variable called state. So I'm going to rename this one to gesture state to not have any conflict. So we have a variable called time, one which is position, one which is velocity, and the last one, position, finished. Okay, since we're going to apply these animations, we also need to create a clock. All right, so again, so what we return is the position, and so we have again 4 states to handle. So first we're going to look, is the gesture active or not? So state, gesture state, equal state dot active, and we need to memorize, when we release the gesture, the position of the offset. So we need to create an offset value. So when we release the gesture, we set offset to state dot position, and when the gesture is active, state dot position is offset plus translation y. So we need to handle 4 cases. This would be the first case. The syntax error here. So here we memorize nicely the position of the scroll. State 1. Now let's do state 2. When we release the gesture, we need to add some decay. So when the gesture is released here, we decay. So we have clock, which means we need to start the clock at the beginning. We have the state as parameter and the config, which is deceleration, and I can give the default value of, I think there is already a default value provided by Reanimated, but here you can just play with how sensitive you want the decay to be. And I think here nothing will happen because we don't set, so nothing happens here because the velocity is 0. So when the gesture is active, we can set the state velocity to velocity y, and we also need to set state dot time back to 0. So it's not getting confused with calculating the delta between 2 frames. So state 1 works, and state 2 we have this nice decay here. Now we need to do the same thing. So when the gesture is active, when the gesture is not active, but when we are outside the boundaries of the scroll view. So let's create a node that will return true if we are within the boundaries of the scroll view. So is in bound. And so first of all, let's calculate our bounds based on container 8 and content 8. So lower bound is 0, right? If the translation is positive, so we scroll down from the top, we are outside the bound. So upper bound actually is 0, no problem. And lower bound is container height minus content height. And since we scroll up, the translation is negative. So I need to multiply by -1. So these are our bounds. And so we are within bounds if the translation y is less or equal than upper bound. So no, if the position, state.position is less than equal than upper bound and greater or equal than lower bound. And all right, so here, if we are not in bound and the gesture is active, for now, we're going to do something very simple. We're going to simply only, so have position to be only 30% or 40%, let's say, of what it should be, of where is the position of the finger. Once we're done, we're going to make it a bit more sophisticated. So let's, for now, just simply, so if not is bound, we set position, so state.position to, we multiply state position by 0.4. Okay. Let's have a look. So you see here it nicely, I mean, you cannot see my finger, but let's say if I put my finger on the big blue circle, it's not following, my finger is not following the position of the blue circle. I'm at 40% of where it should be. So that works well. And if we are outside the bound, so here, if we are in bound, we apply the decay. If not, we need to spring to position. So if not, we spring, we need the clock, we need some configuration. No, we need the state and we need some configuration. So I'm going to create config here. And we're going to need to set the value. So let me create some base config. So I think there's a spring util from reanimated. So make default config. Can I? Okay. So I think, no, I think that's good. And then because the default here is the value of 0, so for 2 value, and here I need to set config to value to either the lower or upper bound. So for this, I'm going to use the snap point function, which is based on the animation value and velocity is going to calculate where the view needs to snap. So it's a function provided by reanimated. So translate state position, state velocity, and the snap points are lower bound, upper. Okay, so here it springs nicely, but I cannot scroll down anymore. And I think, yes, it's, sorry about that, it's content 8 minus container 8. Okay, so now I can scroll down, it nicely decays. And if I reach the bound, it's, so here it springs, but you see then it decays because while springing, it gets back within the bounds and therefore start to decay. So we can avoid this by creating a new animation value. So we can call it is springing. So it's going to be 0 or 1. So if the gesture is active, we set this value back to true. And when we start to spring here, we set it to 1. Is springing to 1. And here it's, if it's in bound and it's not springing, then we decay. So let's have a look. Okay, so now it doesn't decay anymore. We can scroll, decay nicely. If I go to the bottom, so here I have a reset, and I think it's because when I do this here, I always assuming positive value, but it can be actually negative here. So I'm gonna create a node called overscroll, over scroll. So if the state dot position is greater than 0, then the distance, okay, we remove to the distance the upper bound, if not the lower bound, and we subtract this to the state dot position. And now we need here to multiply, so it's 30% of the overscroll, but we need, so to remove from the position this should handle the bottom use case. So let's have a look. So here I have some friction, no problem, and same at the bottom. So that looks pretty good, but let's see if we can do better, because here the friction is always the same, whatever is the position of the finger, which we know, I mean, it feels already pretty good, but we know that's not what happens on iOS. So let's try to apply this formula to see if we can get even a better result. So I'm gonna create a function from this formula. So let's call it friction. So we get a ratio as parameter. So it's gonna be an animated node. And we return multiply, so 0.52 by power of, so sub 1 minus ratio power of 2. That looks good. I need to import up. I have a syntax error somewhere maybe. So that looks good. So now let's see. So now we need to calculate the delta to which we need to apply this ratio, right? This is a ratio that goes to 1 to 0.52 at the beginning and towards 0 at the end. So what we are going to do is we're going to remove this offset variable and call a delta variable, for which we're going to store the difference for each translations. So we're gonna, in delta we'll store the diff of translation, and so here suddenly it's translation y, sorry. So here suddenly position is not offset plus translation y, but it's position plus the diff of the translation, so plus delta. And when the gesture becomes inactive, we don't want the diff to have a crazy value because we already stored in the position. So I'm gonna set translation y to 0. And so here we have position times delta. And so here, if we are not in bound, we are going to do the same, but delta. So we're going to do the same than here, but delta is, and in fact, I'm going to move this here. So if we are in bound, is in bound, we add delta to it. If not, we add delta multiplied by the friction ratio. So I'm going to remove this condition here. So we multiply delta by friction. And here we need to give it a ratio. So the maximum value needs to be, so it goes from 0 to 1. So I'm going to add a mean of 1 here. So to make sure I never give a value as parameter bigger than 1. And I'm going to divide the state position to the container height. So when I reach the end of the viewport, I should get towards 1. Actually, I can get to much bigger than 1 because I can scroll to much bigger than container 8 within one gesture session. But so here the mean will kick in for this case. And at the beginning, it's going to be close to 0. So I'm going to be at friction is going to return 0.52 around this value. But of course, here you could you can tune it to whatever. You could even put 2 times the container 8, for instance. So I need to import min. So this works, and you see now it's becoming harder, and almost now it's almost not moving anymore. So that looks good. I just need to see again. Here I'm forgetting to handle the bottom case. So here it's not, I mean, it's the position, but I'm always thinking in terms of the top scroll. But if I want to handle both cases, it's not the position, it's the over scroll, which we calculate here. So let's have a look. So here it's perfect. And same for the bottom. So now that looks pretty good. I probably actually need here to have the absolute value. So the ratio should always be from 0 to 1. So let's, okay. Yes, much better. So same here from the bottom position. Okay, so that was part 1, to have this bouncing scroll view done from scratch in React Native. Now let's do part 2, which is going to be to detect that we need the search box to appear, and then we need to add the transition for the search box to appear nicely, and we need also to display the icons and with the proper colors and so on, and translate them nicely. So here I'm going to create a translate y variable. I'm going to put, because here we have a state and we want to keep the identity of the animation value, I'm going to wrap it into a use memo 1. So I'm going to return new value, no dependencies, and so we get value from animated. Animated comes from reanimated. So that looks good. I can pass it as parameter to the scroll view. I'm gonna need it also in the search component. And so now in the scroll view, and in the scroll view, we also need to have a non-pull property. So when we pull on the top, we need to set search to true. And so let's do that. So we receive translate y as animated value. And an on pull handler. So now we're gonna assign translate. So this value to the with scroll node. So I'm gonna use the use code hook from reanimated, no dependencies. So I'm gonna use a block. And I'm gonna assign to translate y this node here. And I'm gonna add a condition. So if translate y is greater or equal of a threshold, and the gesture is not active, so and state is not equal to state active, we need to call the onPull function. So here I think I'm losing. I need to add some dependencies here. So container height, because this one is changing from here. Container height, content height, and maybe as well on pull, because I am I mean, I could also put it in use memo 1 just for safety here. I'm gonna put it as dependencies. Okay, so here you see I can trigger the search. Everything works well. And so you see the search here appears very abruptly. So for it to appear nicely, we're going to use a transition. So let's look at the documentation for transition. So we're going to use a transitioning view here. Transitioning we get from reanimated. So we need to give it a transition and a ref as parameter. So a ref I can create here using useRef. And it's the type is transitioning view. And we need to create a transition. So we need one when it appears and one when it disappears. So I'm going to use transition together, and we need in and out. So transition in, transition out. So we need the type and some duration, right? So duration, let's say 400 milliseconds. and type, let's say, scale. Let's have a look. Oops. Okay, I pull. It doesn't work because we forgot to use animate next. So here, if the reference is available, we need to invoke animate next transition. And same when we're closing the search box. Let's have a look. And now it nicely animates. Perfect. Now we can use the translate Y value to animate the search icon. So let's go into the search component. So we get translate Y as the animation value. And the first thing we are gonna need is to animate, so to translate the, but actually we are gonna need to do to translate the search icon and the arrow down button separately. So yeah, we use reanimated, that's good. So here we have the search icon and we have the arrow down icon. And every time we overlay two icons, one the gray one and the one the blue one, and the reason is same for the search icon, and the reason is because we cannot interpolate on the color of the icons, so we can only interpolate colors on views. So I'm gonna wrap these into an animated view. So the arrow down, we can, so style, we can apply directly translate X to it, and the search icon, we're gonna need to clamp the value. So transform translate Y is search translate Y, and for search translate Y we can simply clamp translate Y, so from 0 to threshold. Clamp comes from redash. Let's have a look. Yeah, so that looks good. You cannot see the search icon here actually. Let me add some background to the search icon. So I'm gonna create a background color here. And we're gonna use interpolate colors from redash. So based on translate Y, input range, so we go from header or from 0 to threshold. output range. We go from gray to primary color. And here I have gray and primary like already available as parsed color, so we can interpolate the values quickly. So here I need to maybe be gray, start interpolating much later. And I think here I have container height, which is actually header height. So from header height to threshold. So that's much better. And we can do the same for, so actually I can remove this one, we don't need it. And probably we don't need this one as well. And let's have a look. Perfect. And now we need to, so we have the arrow down gray, the arrow down in primary color. We just need to animate its opacity. So one opacity being the inverse of the other. So I'm going to create opacity. If it's gray, we go from 0 to 1. And then we can create the opposite opacity, which is 1 minus opacity. So when one is at 1, the other is at 0, and vice versa. So we need to import sub, and we're gonna need interpolate. Yeah, it's not interpolate color, but interpolate. Should be here extra. I mean, we don't need it, but it's just because it shouldn't be higher than 1 and lower than 0. So extrapolate clamp. And so I can apply, so yeah, let's use animated view. And I can apply the opacity here. And the opacity, opposite opacity to this one. Let's have a look. Yeah, perfect. So you see the color transition nicely. And up, it appears super nice. So I'm really glad that now we can really easily build this complex physics-based animation. So weaving a really completely seamless gesture and animation. We have a decay, we have a spring, we applied some custom friction function. So we are very now agile in building such a complex gestures and animation. Guys, I hope you enjoyed this example. I'm looking forward to talk to you soon, and in the meantime, happy hacking.